Assalamualaikum, we are from BMMM and we are presenting our assignment which is ceiling mounted cassette. Let's go to the first topic. Very good day. I Muhammad Amar bin Anwar. First, I will explain about the introduction of this assignment. This assessment was given by our lecturer to solve the equation and to recognize all the problem. Our team need to measure all the dimension on each part of the subject from all the lecture and assessment given before. Our team like to practice the studies on the object which is ceiling mounted cassette that had been placed in our faculty. Besides, we need to obey all the law and calculation based on the theoretical studies. Method calculation that we use on this assignment are rigid body, which is fx equal to 0, fy equal to 0, and ma equal to 0. For the measurement and the assumption, this is our assumed measurement that we already measure at ceiling mounted cassette at our faculty. The mass that we already record is 16 kg and the total length around 645 to 648 millimeter. And as you know that measurement are very important before we doing a FBD and doing a calculation on the next slide. So that's all from me about the measurement. I will pass to our next team members for the next topic. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Hadi Nasrullah bin Mustafa Kamal with nomenclature B092110018. Today I will explain about 3D free body diagram in each system structure. Free body diagram. A free body diagram consists of a diagrammatic representation of a single body or a subsystem of bodies isolated from its surrounding, showing all the forces acting on it. A free body diagram, as known as FBD, also called a force diagram, is a graphical illustration. And FBD, it shows all the forces or moment acting on the body. Free body diagram are used, and free body diagram also used to visualize forces and moment that applied to a body and to calculate reaction in mechanic problem. So that we know, a free body diagram is a sketch of the body interest and the forces acting on the body. With the help of a free body diagram, we can precisely define the body or object under consideration to which we are applying mechanical equation and the forces that are needed to be considered. So drawing a free body diagram make it easier for us to understand the forces, torque or moments, and apart from that, it gives us a view of how to apply the proper concept in order to solve our problem. So next is how to draw a free body diagram. First is sketch what is happening. So our group analyze the shape first. Like our group, that is a ceiling mounted cassette, which is the shape is square, and we also analyze that have the four holder. Second is determine the force that act on the object. So our group analyze that the ceiling mounted cassette have the four holder, which make it stick to the wall. So we label it to the force 1, force 2, force 3, and force 4. And then lastly, draw the object in isolation with the force that act on it. So, and lastly, we draw the isolation like this picture. And we draw the shape first, then we analyze and label the force like the picture appear. And the weight and the measurement of the ceiling mounted cassette were given, and we also make some research from another source. So we can see the picture. They have a four holder, like which is force 1, force 2, force 3, and force 4. And the mass is 16 kilogram, and the length were given is 0.65 477 meter. So to draw a free body diagram, we need to draw the object of interest and draw all forces acting on the object and resolve all forces vector into x and y component. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh to Dr. Fuad and my fellow friends for this subject static. My name is Muhammad Mizdin bin Abdul Qadir. My number entry is B0921104113. Thank you to previous presenter to give me a chance to explain about equation of equilibrium EOE for calculation about icon cassette. Next, this is our calculation we have get from the lab. We have to find the reaction force on support bar, or we call that is point dB, and the last is distribute force on the load. First, to find the reaction force in this data, we use clockwise plus positive clockwise plus sum MA equal to 0. The data we have get from the lab is negative 156.96 times 0.836 plus Cx times 2.5 equal to 0. That we can get for negative 140.636 plus 2.5 Cx. We have to find the Cx. To find Cx is using formula sum Fx equal to 0, Ax minus Cs equal to 0, Ax minus 56.264 equal to 0. That Ax we can get 56.264 Newton. Here we can assume that Ax equal to Cx. Next, we continue to find the support bar. To find the value of support bar, we using a same formula that we can get the Fd equal to negative 316.036 Newton. Now we have two data, Fd equal to Fb. Now we have to find the force at member CDE using a formula Fy equal to 0, Cy plus Fd sine 45 minus 156.96 equal to 0. Then we can get the answer for Cy equal to negative 66.51 Newton. Next, we want to find the distributed force on the load. We use a formula F1 equal to F2 equal to F3 equal to F4. Why we use F1 equal to F2, F3, F4? Because we have four supported for the same space. Then using this, we fill in the formula that the value we get it from above. Then we can get F2 equal to F4. Now we must to check the answer. Then is it true or false? F1 plus F2 plus F3 plus F4 minus negative 156.96 equal to 0. Now we can get the answer 339.24 Newton times 4 minus negative 156.96 equal to 0. Then the answer is 0. Now I will pass the next member to present their part. Thank you.
Hi everyone, my name is Yap Chong Ming and I'm from BMMM Session 1 and my metric number is B0921102113. And now allow me to start with the force analysis part. From the free body diagram, we got to know that the forces for F1, F2, F3 and F4 is equivalent, and this can be concluded by the ceiling mounted cassette is fixed on the wall. And if the forces is not equivalent, and if, for example, F4 has a higher force compared to others, it will cause the system to start to rotate. And since the force is equivalent and there is no rotations on the systems, hence we can conclude that the moment on the system is equal to zero. By having these two theories, we can calculate the force acting on the rigid body. After those calculations, we got the force acting on the body is equal to 39.234 Newton for F1, F2, F3 and F4. Moreover, based on Newton's law of motions, which states that when two bodies interact, they apply forces to one another that are equal in magnitude but opposite in directions. Hence, we get to know that there are force acting downwards which causes by the gravitation. Next, since they do not have any forces acting on the x and y directions, hence the force acting in the x and y of the body is equal to zero. Because the force that holding the cassette on the ceiling is in the z direction only based on the FBD that we have drawn. And finally, to stabilize the systems, the force and moment is important and cannot be ignored. They are depending on each others. The bigger the force, the greater the moment. And I think that's all for my parts. Thank you.
Hi, my name is Renko with number matrix B0921104442. Today I will presenting about conclusion. Based on the free body diagram of the actual structure, we can evaluate three systems, which is Rx, Ry and Ma. The ceiling mounted cassette is the cantilever structure and it is fixed support beam. The distributed load of the ceiling mounted cassette has been reduced to a single force. Then the normal force is equal to weight of the load. The support reaction forces of the chosen rail structure, which is a truss, had been calculated through this assignment. All data had been recorded and presented in the form of poster and recorded video, and the objective of this assignment has been achieved.
That's all from us. Hope you understand our presentation. Thank you very much.